The question is here, different complexes has been given, cobalt, copper complex. Here different ligands also are there in the complex compounds. The order of ABCD, these four compounds, in terms of wavelength of light absorbed is. Okay, this concept is from CFSE, crystal field stabilization energy of complex compounds or coordination compounds. So we know that we have studied spectrochemical series for different ligands. Whatever the ligands, strongest ligand will be having splitting, stronger splitting. For example, metal is here, ligand is approaching the metal atom. So ligand is donating the pair of electron, lone pair of electron to the central atom. In central atom, d orbitals are there. D orbitals. Whenever this ligand is approaching, d orbitals split. D orbitals split due to repulsions based on the approach. If this ligand is approaching along the axis, whatever the orbitals are there, they moves up, they will get higher energy because of repulsions. So this only we show with splitting of d orbitals like this. So T2Z and EZ, if octahedral splitting and tetrahedral splitting, two different splittings are there within your syllabus. So whenever the ligand is approaching the metal, splitting will take place. So according to CFSE, the energy difference between the two d orbitals, two set of d orbitals, will be purely depend upon the three factors. If the splitting is the more, then what will happen here? D electrons will excite from lower energy to higher energy, and that causes some absorption of energy from the visible light. If energy gap is more, so more frequency it will take from the visible light, means more wavelength portion of the light. For example, VIBGYOR, if you take it, left side portion in the visible light, they are having the more frequency. Just after ultraviolet, violet color is there. So they absorb this color, so complementary color like red color will be ejected out. Now what I am saying, here four different complexes are there. So each complex is like having different set of ligands. For example, if you take it copper, H2O, here H2O is there and ammonia also is there with cobalt. Now spectrochemical series, if you take it, spectrochemical series, order of the ligand is given by spectrochemical series, order of the ligand causing splitting. So strongest ligand, carbon monoxide, CO ligand, then CN ligand causes more splitting, then ammonia, then thiocyanide and water, OH minus, Cl minus, S2 minus, Br minus and I minus, so on. So how you can remember this spectrochemical series easily? If the carbon ligands with the negative charge, carbon donors with negative charge, then nitrogen donors with negative charge, then oxygen donors with negative charge, then halogen donors with negative charge. So carbon donor with negative charge, they act as very strong field ligands. Why? Because carbon is not that electronegative. Lone, whatever the negative charge is available on the carbon, that will be available outside easily. Why? Because carbon is not pulling towards inside. This negative charge is there freely available. If that is approaching the metal atom, central metal atom, so the d orbital splitting will be more, so it causes more splitting. Why? Because carbon is not that electronegative. But here halogen atom, if you take it, X minus ions are more stable because of more electronegativity. So this negative charge is pulled towards the center. So negative charge is not that much available to cause splitting in d orbitals of central metal atom. So splitting will be less, so that's why halogens causes less splitting of d orbitals. This is the concept. So clearly we will check it one by one. What are the ligands? Here if you take it, CO not there, but CN is there. So here 6 CNs are there. So this will be the strongest more absorption will be there in B. I will tell you later absorption. First wavelength. First we will tell which one will be having largest CFSE, B. And then if you take ammonia, here also ammonium 5 ions are there, here also ammonium 5 ions are there. Here H2O is there, neutral oxygen atom, less splitting if you are comparing with nitrogen containing ligand. But the thing is here, cobalt is in +2 oxidation state in this complex, here +3. Whenever +3 charge, no, less size is there. Why? Because effective nuclear charge is more here, more positive charge is there, that attracts very strongly. Size is small, cobalt. Whenever size is small, splitting will be more. Why? Because atom is small. The d orbitals are near to the nucleus. So whenever other atom is approaching that, splitting will be more. So +3 oxidation state there. 3 factors I told here, I did not mention 1, 2, 3. So first one is based on central. There are 3 factors I told which can decide the spectrochemical series. In first one, you can say exactly ligand nature. So that only I am telling like spectrochemical series. Second one is metal ion charge. Central metal ion is there, that charge. If charge is more, splitting will be more. Next, metal position in the periodic table. Metal position means the size. If you take d orbitals, d block elements like chromium, manganese, iron, cobalt, zinc, that position also, small the size, more the splitting. So these are the 3 factors which causes effect on crystal field stabilization energy. So first what I am saying, B is having more this one because of strong field ligand, and cobalt also is in +3 oxidation state. Here cobalt, if you take it in +3 oxidation state, and 5 ammonium ions are there, here also 5. Cl anyhow weak field ligand, but H2O if you take it, here oxygen is there. Oxygen, even that is neutral ligand, oxygen is the donor atom, and here also +3 oxidations is there. Okay, I did not check. Cl minus. So if you send here also +3, here also +3 oxidation state is there, but here chlorine is there, here we are having H2O. So splitting should be more in C. And then okay, if you take here, there are D and what else are there, B over C over and A and D. If you take it clearly, here 5 nitrogen donating ligands are there, so A it will be more, and finally D. This is the this is the order for splitting, causing of splitting. If more the splitting, what the given in terms of wavelength of light observed, the correct order in terms of wavelength of light observed. So in terms of wave number they have asked, means more frequency, wave number, more energy. So where that more energy will be taken, wave number is equal to 1 by lambda. So more energy, which one it cause more, this one. So this is the order.